This is just a quick look over of what should be on pages 36 and 37 of your notebook. It doesn't matter which place you put it, but if you were out on Monday, the 17th of September, this is what we did right here. So we went over these notes in class. So you can pause the video or you can get one of my notebooks and make sure you have all of these things filled in. So this first part up here is telling us the subatomic particles, the protons, neutrons, and electrons. Those are the things that are within the atom. These are just some common abbreviations that we use in class, nothing official. The charges of each one and the location of each one. Protons and neutrons are in the nucleus, electrons are in the electron cloud. Then we just did a quick little diagram of the atom itself, protons and neutrons showing in the nucleus, electrons showing around the nucleus on the electron cloud. Now we usually will show electrons on a path that we call orbitals. So our next section here, we're talking about just electrons specifically. I'll move this down just a minute. And electrons have energy levels or shells, sometimes called orbitals, so those things can be called those three. Electrons can be lost, gained, or shared with other atoms. The valence electrons are the electrons in the outermost shell. Stable elements will have 8 electrons. 8 valence electrons, Exception is hydrogen and helium, and those are stable with 2 valence electrons. And that goes to the octet rule. The octet rule tells us that elements will tend to combine so that there's 8 valence electrons. So underneath here, you can see that there are 7 energy levels, and the row that they are on the periodic table, the rows that go across. So if they're in the first row, hydrogen and helium, they have 2 energy levels, or they have 1 energy level because they're in the first row. The second shell is in the second row, so they have 2 energy levels. So the things that we're looking at here is that there are 7 energy levels. They do have names. That's not really important to us right now. It will be more important to you in chemistry, but these are kind of the things that will be important. Those first 3 are the most important to us, 2, 8, and 8. That's the number of electrons that it can hold. On the back side of this sheet, we filled in these squares. We talked about elements being pure substances because they're made of one type of atom. Pure substances meaning they're the same thing throughout. Elements make up everything in the universe. The periodic table organizes those elements into 18 family groups. Those are the ones that go up and down. And elements in the same family share the same number of valence electrons and also the same reactivity. There are 7 periods. Those are the ones that go across on the periodic table, and elements in the same period, that was a little typo, so correct that. Shouldn't say family, it should say period, have the same number of energy levels. Then down here we looked at how to read the square. Remember, you've got your atomic number, your symbol, your name, and the mass. The atomic number, this is the one at the top, is going to tell us the number of protons. The atomic mass is the number of protons and neutrons in the nucleus on average. So those two are added together. So again, your atomic number down here is going to show us protons and electrons if the atom's neutral. And then in order to get the number of neutrons, you have to subtract 12 minus 6, the mass minus the number of protons, or the mass minus the number. Then over here, we just filled in that same information again about carbon. Carbon has 6 protons, 6 electrons, and these little explanations here tell you, again, the electrons can change, protons cannot change. If the protons change, your whole element changes. And then 6 neutrons, because we did the little math there. So just using that information. And then we did a Bohr model and a Lewis structure. So the Bohr model is, it shows all of the protons and neutrons in the nucleus, so 6 protons, 6 neutrons for carbon. And then we started placing the electrons, and this is out here, these rings are your electron cloud. We're just placing those in orbitals. So the first orbital, the one that's on the inside, you always start there first. So the first orbital can only hold 2, and the second orbital can hold up to 8. Carbon has 6 electrons, so we put 2 on the first shell and 4 on the second shell. That gives us the total of 6. So when we look here, carbon has 4 valence electrons. The Lewis structure only shows the valence electrons. So you put the symbol for carbon and you put 4 dots showing the 4 valence electrons only for your Lewis structure. All right, we tried beryllium in class. This is our box for beryllium. So we put our protons and neutrons in the nucleus, and then we drew our electron cloud with the energy levels. It has 4 electrons because if it has 4 protons, it also has 4 electrons right now. So we put the first energy level, and it has 2 because it's full after 2, and the second energy level can hold up to 8, but beryllium only has 4, so we place 2 there. So in the Lewis structure, we only place the valence electrons. Those are only the ones in the largest, the outermost shell. So the outermost shell only holds 2, so there's 2. And then we did some practice. Which atom is which is the first thing that we practiced. And what we did is we identified these models, these are Bohr models, by counting the number of white dots in the center. The number of white dots represents protons. So this one has 6, so we go to the periodic table and look for atomic number 6, which is carbon. This one has 10 white dots when we count them, so we go to the periodic table for number 10, and that's neon. So if you want to pause this and make sure you, or practice this, and then make sure you can get the right answers from just looking at a Bohr model. And then on the inside we practiced here. We practiced filling in the square, so there's the answers for the inside. You can pause and make sure you understand how to do this. If not, go back to your notes, look at the square, because all we're doing is pulling the information out of the box and placing the atomic number, the mass. Remember, protons and electrons are the same as the number, and neutrons you have to subtract the mass minus the number of protons. So in this case, 16 minus 8 would give me 8. So practice those, make sure you get the right answers. And then over here, these were the models that we drew, so you can pause right there. We did not end up doing zinc because it was just too much. So pause there and get those. And then there's your boron on the bottom. And that's all for page 36 and 37.